Okay, today we're going to be talking about how to solve differential equations by separating the variables with some sort of initial condition. So it says given the differential equation dy dx equals 2x over y, solve for y as a function of x, given that y of 1 is equal to negative 3. So in other words, we have the ordered pair 1, negative 3. So what we want to do is we want to get all of the terms that have a y on the left and everything that has an x on the right, and then integrate with respect to that letter on that side. So we're going to have dy dx equals 2x over y. I'm going to go ahead and multiply both sides by y. And that's going to give me y dy over dx equals 2x. And then I'm going to go ahead and multiply by dx on both sides. It's going to get rid of that. So over here I have y dy is equal to 2x dx. Now I'm going to integrate this side with respect to y, and I'm going to integrate this side with respect to x. When I integrate y, I get y squared over 2. Technically there's a plus c right here, but I'm going to move the constant over to this side so that we don't have two constants. We'll combine them into one constant. This is going to end up giving us x squared plus a constant. At this point, we're able to plug in our initial condition to get our c's. So when x is 1, y is 3. Negative 3, excuse me. So negative 3 squared is going to be 9 over 2, and that's going to equal 1 plus c. So I can multiply everything by 2, and that's going to give me 9 equals 2 plus 2c. So subtract 2, and my c is going to end up giving me 3.5, or actually make it a decimal, excuse me, a fraction, 7 over 2. So now we're going to go back, and we have y squared over 2 equals x squared plus 7 over 2. And once again, I'm going to get rid of the 2's by multiplying everything by a 2. So that's going to cancel, that's going to cancel, and that's going to leave me with y squared equals 2x squared plus 7. I'm going to take the square root of both sides, and technically I would need to put a plus or minus in front of this, but we have to choose which one it is. And notice that when x is 1, y must be negative 3. So therefore, I need to put a negative out in front of this square root so that when I plug in a 1, I get negative 3. Let's test it out. 1 squared is 1, times 2 is 2, plus 7 is 9. The square root of 9 is going to give me 3, but it will be negative only if I put a negative in front of the square root. And so don't put plus or minus on your answer. Make sure you choose whether it's plus or minus. Okay, and this next example is very similar. We have the ordered pair 3, 4, and we want to separate the variables. So y prime is another way of saying dy dx, and we have x squared square root of y. So I'm going to go ahead and divide the square root of y over here. So it's going to be 1 over the square root of y. And then over here I'll have x squared dx. And I'm going to move this up to the top and make it y to the negative half. And this is going to be, and actually this needs to be dy, excuse me. And this is going to be x squared dx. Okay, now I'm ready to integrate both sides. So when I integrate y to the negative half, I have to add 1 to the power, which is going to turn it into a positive 1/2. So let me go ahead and do that. But then when I divide by positive half, it's the same as multiplying by 2. So that's going to end up giving me 2y to the half power. And then over here, if I integrate this, it's going to give me x cubed over 3 plus a constant. All right, now at this point, we're able to plug in our initial condition. So when x is 3, y is 4. So I'm going to have 2 times y, which is the square root of 4, same as thing as the half power. And then x is 3, so that's going to be 3 to the third. That's 27 divided by 3, that's 9, plus c. Square root of 4 is 2 times 2 is 4. And so my c is negative 5. So now if I go back, I will have 2 times, I'm going to just change this as the square root of y equals x cubed over 3, and it would be a minus 5. All right, so now I'm going to divide by 2, and I'm going to divide this by 2 and divide this by 2. So that's going to give me the square root of y equals x cubed over 6 minus 5 over 2. And then I'm going to square both sides to get rid of this square root. So it ends up being y equals x cubed over 6 minus 5 over 2, and then this squared. Now always check and make sure that your answer works for your initial condition. So when x is 3, we should get 4 as our y. So let's check it. 3 to the third is 27 over 6. 27 over 6 minus 5 over 2, which if I get a common denominator, that's going to be 15 over 6. 27 minus 15 is 12 over 6, which is 2. And then when I square it, I get 4. And so we have checked our answer. So the final answer is y equals parentheses x cubed over 6 minus 5 over 2 squared. All right, so we have the initial condition here, 2, 1. And so we're going to separate our variables once again. So that's going to end up giving me 1 over y squared dy, and then 4x dx. And now I'm going to integrate both sides. So to help me, I'm going to move this up to the top and make it y to the negative 2. And I will go ahead and integrate this. That's going to give me 2x squared plus c. So if I integrate this, I have to add 1 to the power. If I add 1 to the power, that's going to give me y to the negative 1. Divide that, and that's going to give me negative 1 over y, essentially. So you can work that out there, and then 2x squared plus c. Now I'm going to plug in my initial condition. So x is 2, y is 1. So when y is 1, I have negative 1 over 1. And then 2 squared is 4 times 2 is 8 plus c. So my c is going to be negative 9. All right, so now I am going to go back here, and I'm going to say negative 1 over y equals 2x squared minus 9. Now I'm going to make this 2x squared minus 9 over 1 so that I can make it a proportion. And that way I can cross multiply. So I'm going to take y times 2x squared minus 9 equals the product of this, which is negative 1. And then I'm going to divide by 2x squared minus 9, 2x squared minus 9. So my y is going to equal negative 1 over 2x squared minus 9. Well, let's see if we get the correct answer. When x is 2, 2 squared is 4 times 2 is 8, and 8 minus 9 is negative 1. So negative 1 over negative 1 is a positive 1. And that's what our initial condition should be. Okay, example 4 here. And once again, same situation. We have our initial condition of 0, negative 2. Make sure that we pay attention to the fact that it is indeed negative. So we want to separate our variables once again. So this is going to end up giving us, if I divide by y, it's going to be 1 over y is equal to, 1 over y dy, is equal to 9x squared dx. So now I'm going to integrate both sides with respect to that letter. When I integrate 1 over y, that just gives me the natural log of y. When I integrate this is going to give me 3x cubed plus a constant. And so now what I'm going to do is I'm going to rewrite this equation. I'm going to do something a little bit different. I'm going to rewrite this equation so that it is in exponential form. So I'm going to take the e, I'm going to raise it to the other side and set it equal to y. So e to the 3x cubed plus c. Make sure you know that the plus c is with the exponent. It's not here as a constant. And then that's going to be equal to y. Now notice I'm not plugging in my initial condition to get c at this point. I'm going to rewrite this. I'm going to do something a little nifty. I'm going to separate this and make it e to the 3x cubed times e to the c. And the reason why I'm allowed to do that is because I know the laws of exponents teach that if you have a like base, then the exponents are added when you multiply. So if I see exponents that are already added, I can go backwards and write these as like bases that are multiplied. Now, how does that help me? Because e is just a number, 2.718, Euler's number, and I'm going to raise that to some other unknown number. As a result, that's going to turn it into some new constant, and I'm going to call that c, e to the 3x cubed. So this, in other words, is just going to turn into some new constant. Now that I have that, I'm going to now plug in my initial condition. And so now I'm going to plug in my 0 for my x and -2 for my y. So c, e. Now, when you plug in 0 for x, this whole exponent becomes 0, and my y is -2. E to the 0 is simply 1, so my c is -2. So my final answer is going to be y equals -2 e to the 3x cubed. Now let's see if our initial condition holds up. If I plug in 0, I have 0 as my x, which is going to make the exponent 0, and e to the 0 is 1 times -2, and so we have an equation that makes our initial condition true. Okay, example 5, we're going to do something a little bit similar here. And I'm going to divide by y plus 3, so that's going to give me 1 over y plus 3. And that's going to equal 1 over x squared dx. And I keep forgetting the dy, don't know why. So now I'm going to be integrating both sides. And 1 over y plus 3. Now let's just do a little u substitution here. U is equal to y plus 3. So du is going to be dy. So now I can say this is going to be the integral of 1 over u, and dy can be replaced with du. And I know that the integral of 1 over u is simply going to be the natural log of u. But I know u is y plus 3, so natural log of y plus 3, absolute value. And then that's going to be equal to the integral of 1 over x squared, which you can work out on your own, but that's going to be -1 over x plus c. And you get that by basically taking the x squared and moving it up to the top, making it a -2, and then adding 1 to the power and dividing by that result. So now I'm going to do the little thing where I rewrite it in terms of an exponential. So e to the -1 over x plus c equals y plus 3. Now I'm going to separate this just as I did in the last problem, and I'm going to make it e to the -1 over x times e to the c equals y plus 3. Now e to the c, as I said before, this is just another constant. So therefore, I'm going to rewrite this as c e to the -1 over x minus 3, so I'm going to move the 3 over, equals y. Now I'm going to plug in my initial condition. So when x is 2, y must be 1. X is 2, so c e to the -1/2 minus 3, and y is 1. So c e to the -1/2 equals 4. All right, so now I'm going to divide by e to the -1/2, divide by e to the -1/2, cancel. So my c is going to equal, if I move this e to the -1/2 up to the top, it's going to be 4e to the half. That's my c. So now I'm going to go back in and actually plug that c back in. So this is going to give me 4e to the half times e to the -1 over x, minus 3 equals y. So this one's a tricky one. And now I have like bases again, e and e. So therefore I can combine my exponents So my final answer should be y equals 4e to the parentheses, I guess, 1/2 minus 1 over x, and then minus 3. Now let's see if our initial condition holds true. When x is 2, y must be 1. Well, if I plug in 2 for x, I'm going to have 1/2 minus 1/2, which is 0. E to the 0 is 1, times 4 is 4 minus 3 is 1. Okay, in this last example, we have to do something a little bit different here. What we want to do here is we want to recognize that we can factor out a 4x cubed. So let's go ahead and do that. We factor out a 4x cubed, and when we do that, we have y plus 3. Let's make sure that that is true. 4x cubed times y gives you 4x cubed y. 4x cubed times 3 is 12x cubed. So then now that's going to equal dy dx. So we're going to separate our variables. So we're going to have 1 over y plus 3 is equal to, and keep doing that, dy. And then 4x cubed dx. So now we're going to integrate both sides. We've done this in the last problem. If we do a little u substitution, that's going to end up giving us the natural log of y plus 3. And then here, this is simply going to give us x to the 4th plus a constant. Now once again, this is about the third time that we've seen this in a row. So we're going to do the little around the world guy, and we're going to do e to the x to the 4th plus c equals y plus 3. And we're going to do this whole idea that we separate it into e to the x to the 4th times e to the c equals y plus 3. E to the c is just another constant, so it's going to be c e to the x to the 4th. And I'm going to subtract 3. That's going to give me my y. Now I'm ready to plug in my initial condition of 1, negative 5. So when x is 1, I'm going to get e to the 1st, essentially, minus 3 equals y. And y is negative 5. So I'm going to add 3 to that side, and this is going to give me negative 2. So now I'm going to solve for c, and that's going to give me negative 2 over e to the 1st, or negative 2 e to the negative 1. So now I'm going to go back, and I'm going to plug that c back in. So that's going to give me negative 2 e to the negative 1 times e to the x over x to the 4th minus 3 equals y. So I have a like basis, so I'm going to say negative 2 e to the x to the 4th minus 1, because I can now add your exponents together, and that's going to be minus 3 equals y. Now let's check and see if our initial condition holds true. So when x is 1, 1 minus 1 is 0, e to the 0 is 1 times negative 2, and negative 3 add up to negative 5. Bingo, we are done.